Okay, this is Math 105, section 5.1. Okay, we're going to start with trig by using the unit circle approach. Okay, so we go back to our unit circle. A unit circle is a circle with center of 0, 0 and a radius of 1. So remember, it looks like this if we do the full, the center. Where our h and k is 0, 0, right? X minus h squared plus y minus k squared equals r squared. So center 0, 0, radius is 1, and that just simplifies to x squared plus y squared equals 1. So there's our unit circle, center 0, 0, radius of 1. Okay, and that kind of, we talk about trig functions, they're all based around points on this unit circle. Okay, so the equation of the unit circle is x squared plus y squared equals 1. Okay, so just defining it, unit circle, circle of radius 1 centered at the origin. Okay, which is the equation is x squared plus y squared equals 1. Okay, now for example, suppose you want to show that a point is on the unit circle. All we have to do is show that x squared plus y squared equals 1. So if this is our point where x is square root of 3 over 3 and y is square root of 6 over 3, just square x and square y and add them and see if you get 1. Square root of 3 over 3 squared is 3 ninths. Okay. Square root of 6 over 3 squared is 6 ninths, and we add that up, we get 9 ninths, which is 1. So we can say yes, it is on the unit circle because you take x squared plus y squared and you get 1. Okay. Now, we talk about trig functions, we're going to use these numbers, okay? This is actually when we form an angle and we get to this point on unit circle, the cosine of that angle is going to be the x, okay? And the sine of that angle is going to be the y, but we'll get to that. Okay, now let's talk about terminal points on unit circle, okay? Suppose little t is a real number, okay? And we'll mark off a distance t along the unit circle, starting at the point 1, 0, okay, and moving in a counterclockwise direction, okay, if t is positive, or in a clockwise direction if t is negative. So, sorry, we move counterclockwise if t is positive, okay. So this would be t. We start here, and t positive means you move counterclockwise, and t negative means you move clockwise, okay. So we start at this point, okay, on the x-axis, which is 0.10, okay, and we move this way for t positive, and this way for t negative, and our terminal point is where we end up when we do that, so that we get a point in xy there, or an xy here. Okay. So we arrive at a point called pxy on the unit circle. Okay, x and y are our coordinates. Okay, this is called the terminal point, determined by the real number t. So t was the distance that we moved along that circle. Okay, so let's write that out. Along the unit circle. Okay. Now remember, the circumference is 2 pi r for a circle, right? So our circumference of the unit circle is c equals 2 pi times 1, which is 2 pi, okay? So if we start at 1, 1, and we move counterclockwise all the way around the unit circle, and return to 1, 1, then you're traveling a distance of 2 pi, because you want the full circumference, 2 pi times 1, okay? If we move halfway around the circle, you're going half of 2 pi, which is pi. Okay? Distance is pi. And to move a quarter of the circle, we move a distance of 1/4 times 2 pi, which is pi over 2. Okay? So we can measure those distances as fractions of 2 pi, because 2 pi is a distance all the way around the circle. Okay? So here we can see, here we're starting here, we're going red, we're going counterclockwise, so we're going positive. T equals pi over 2 would just be a quarter of the way, right? T equals pi would be half the circle, okay? And we end up, and notice the terminal points here. Pi over 2, we ended up at 0, 1, right? Pi, we end up at minus 1, 0, remember, because we're at the unit circle. And this would be 3 pi over 2, so this is a pi and a half, right, basically. 3 pi over 2, we end up at the point 0 minus 1. And then if we go the full 2 pi, we just end up where we started, right? Okay. So those are our distances traveled on the unit circle, okay? And our terminal points are, for pi over 2, it's 0, 1. For pi, it's minus 1, 0. For 3 pi over 2, it's 0, minus 1. And for 2 pi, it's back to 1, 0 again. Terminal point being the point where we end up on the circle. Okay, so let's look at an example. For t equals 3 pi, Now pi is half a circle, so we go 1 pi, 2 pi, 3 pi. Our terminal point is minus 1, 0. Minus pi, we're going to go backwards, right? So we're going to go clockwise. So minus pi is minus half a circle, and we end up at minus 1, 0. Minus pi over 2, we go backwards, and we're going to go quarter of the circle. So that takes us to 0, minus 1. So those are our terminal points for these three values of t. Now suppose we go not quarter of the circle, but an eighth of the circle. So we go up halfway to the quarter point. Here our t is pi over 4. Okay. So we're taking 2 pi divided by 8. It's 1/8 of the circle. And it's the same distance from 1, 0 as from 0, 1 along the unit circle. Okay. And you can see that we're going halfway between here and here, right? This is pi over 2 if we go up to here, but we're going pi over 4, we're going to half that distance. Now, that means x and y are the same. So we have this. X squared plus y squared equals 1, but they're going to be the same here because we're on the line y equals x, right? So this is how we get these numbers. First of all, since the unit circle is symmetric with respect to the line y equals x, P lies on the line y equals x when we do that. Okay, so P is the point of the intersection in the first quadrant of these two graphs. X squared plus y squared equals 1 and y equals x. Okay. In other words, we don't have to use y squared. We can use x squared instead because x is equal to y. Okay. So if we substitute that here and y equals x into here for y squared, we can use x squared. Okay. Now we have x squared plus x squared equals 1, which gives us 2x squared equals 1, combining like terms. Okay. Okay, so now we have x squared equals 1/2. We divide both sides by 2. Taking the square root of both sides, we get x equals plus or minus 1 over square root of 2. Taking the square root of 1/2. Okay. Now, since P is in the first quadrant, okay, and since y equals x, we also have y equals 1 over square root of 2. Okay, so we can say that x and y are the same, right? Because we're on the line y equals x. So the terminal point determined by pi over 4 is square root of 2, 1 over square root of 2, which is square root of 2 over 2. Square root of 2 over 2. And we can, what we did was we rationalized the denominator there. So 1 over square root of 2 times the square root of 2 over square root of 2, right? Okay. So that gave us the square root of 2 over 2. That's how we got these numbers here, okay, by rationalizing the denominator from 1 over square root of 2. And remember, that came from x squared equals 1/2, which gave us x equals plus or minus square root of 1/2, or 1 over square root of 2. Okay? Because we know x and y are the same, and x squared plus y squared equals 1. Okay, and we can use similar kind of method to find different numbers along the circle. Okay, so here we did pi over 4, right? We did pi over 4, which is halfway up the quarter way point, right? So we're going halfway from here to here. Okay, and we got square root of 2 over square root of 2 over 2. Okay, x and y are the same, right? Here. Now here we have square root of 3 over 2 and square root of 1 over 2, but we write it as 1 over 2. Okay, that's pi over 6. Now that would be a third of the way up here. Okay, third of the way on that first quarter. Okay, pi over 3 would be 2/3 of the way, and that gives us square root of 1 over 2, or 1 over 2, and square root of 3 over 2. Okay, and we know these terminal points, 0 and pi over 2. We already did those, right? So, and I'll show you how we get those in class. But the terminal points for pi over 6 is square root of 3 over 2, 1/2. Okay, the square root terminal point for pi over 4, which we just did, is square root of 2 over 2, square root of 2 over 2. These are x, y pairs, right? Terminal point for pi over 3 is 1/2 square root of 3 over 2, and then we know that the terminal point for pi over 2 is 0, 1, getting up here. So I'll show you how we get those, and it's maybe a little bit easier to see using triangles, but we'll take a look at that in more detail in class. Okay, let's look at some examples. Let's say t equals minus pi over 4. Let P be the terminal point determined by minus pi over 4, and we'll let Q be the terminal point determined by plus pi over 4 to start. And notice that Q gives us, pi over 4 is this way, gives us plus square root of 2 over 2, plus square root of 2 over 2. If we go the opposite way, what happens? Well, the only thing that changes is our y. Our x stays the same. So our terminal point is going to be plus square root of 2 over 2, and then the y will be minus square root of 2 over 2. So the only thing that changes is the y. You know, there's these exact same points otherwise. If you go plus this way or minus this way, the only thing that's different is your y. The x is exactly the same. Okay, so our terminal point would be plus square root of 2 over 2 for the x and minus square root of 2 over 2 for the y for p. And then p is from going this, you know, in the negative direction for pi over 4. Okay, let's look at 3 pi over 4. Okay, that means we go, now if we go pi over 4, it's halfway, halfway, halfway. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, and then that's going to take us to the same points here, except now the x is negative and the y is the same. Okay, so it's still in reference to this q. Okay, we have the same numbers, but the x is going to be the opposite. We have the symmetry across the y-axis, right? Which means your x changes, your y doesn't, right? So now the terminal point for 3 pi over 4, which is p, will be minus square root of 2 over 2 and plus square root of 2 over 2. Okay. Now let's do minus 5 pi over 6. Okay. So we'll start with pi over 6, which takes us here, right? 1/3 of the way up, you know, as we go to first, you know, the first quadrant. Okay. And if we remember, that point is square root of 3 over 2 and 1/2, right? Okay. Minus 5 pi over 6. Now if we go pi over 6, every pi over 6 we do 3 times, it takes us to the quarter. So this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay. If we go backwards, it's like this: minus 1 pi over 6, minus 2 pi over 6, minus 3 pi over 6, minus 4 pi over 6, minus 5 pi over 6. Takes us over here. And actually, you can see that symmetry, right? Now, x and y are the same numbers, but the signs change, okay? So if this point is square root of 3 over 2 and 1/2, this point is minus square root of 3 over 2 and minus 1/2. And that's our terminal point for minus 5 pi over 6. So we're relating it to plus 5 pi over 6 using that symmetry, okay? The first one used symmetry across the x-axis, we changed the y. The second one we used symmetry across the y-axis, we changed the x. Now we're using symmetry across the origin, right? We're going 180 degrees from there, half a circle, and that takes us to changing the x and the y. Okay, so that takes us to the concept of reference number, and this is important, and this is how we look at trig related to first quadrant numbers. Okay, from the examples, we see that to find a terminal point in any quadrant, we only need to know the corresponding terminal point in the first quadrant. So we're basing everything on the first quadrant. So we're going to use what's called reference number, will help us find those terminal points. Okay. Okay, so this is the idea. Reference number. Let t be any real number. Okay. The reference number t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So basically what we're doing is taking the shortest path to the x-axis. And that equals our t bar. Okay, so we're taking the shortest path to the x-axis along the unit circle. So for example, if our t is just going to here, right? Well, our t bar is the same distance, right? Because we're taking the shortest path. We have to go back to the x-axis that way. Okay. If this is our t, the red here, okay, positive, our t bar is just the extra distance we have to go to get to the x-axis, which is just this amount. Okay. And we think of it as always positive, so we don't worry about the negative. Okay. If our t takes us all the way over here into the third quadrant, our t bar is just the distance we have to back up to get to the x-axis. We're taking the shortest path to the x-axis. Okay. If we go all the way around for our t and we end up in the fourth quadrant, our t bar is just the extra distance we have to go to get to the x-axis. So we're going to use t bar as our reference as like a first quadrant measurement to get our reference numbers. In other words, they use the same numbers, we just have to change the signs. Okay, so let's look at some concrete examples. Let's say t equals 5 pi over 6. Okay, 5 pi over 6, remember we did minus 5 pi over 6 and we ended up over here? Well, if we do plus 5 pi over 6, we're going to go counterclockwise and end up here. Okay, and then so that's our t. Our t bar is just the extra distance we have to go, which is pi over 6. So you remember you had 5 pi over 6 plus pi over 6, you get 6 pi over 6, which is pi, which is half the circle. So there's our reference number t bar. Okay. If we go 7 pi over 4, now remember pi over 4 is halfway up the quarter. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 takes us halfway into that fourth quadrant. Our t bar is just the extra distance we have to go to get to the x-axis, which is pi over 4. Okay. Let's look at some negatives. T equals minus 2 pi over 3. So pi over 3 is like that, and then 2 pi over 3 is like this. So you can think 3 pi over 3 is half the circle. We're going to do 2/3 of the way, halfway through the circle. Okay, so minus 2 pi over 3 takes us this way, going clockwise, right? And the additional distance we have to go to the x-axis, the shortest path, is pi over 3 would be our t bar. Okay, remember, because 2 pi over 3 plus pi over 3 gives us 3 pi over 3, which is pi, which is half the circle. Okay, and let's use a number. Usually we just use, pi, fractions of pi. It's a little bit easier. T equals 5.80. So if we go 5.80, you go all the way around. Now 2 pi radians is, just so we get an idea, 2 pi is about 6.28. We're not talking about radians yet, but we're looking at 6.28, right? So if we, remember, because pi is 3.14 approximately. So the full circle would be 6.28 distance traveled. So we went 5.8, and the additional distance would be 0.48. Okay, so that would be our t bar. Just using 6.28 as the total distance around, using 2 pi is about 6.28. Okay, so let's summarize how we're using reference numbers to find our terminal points. Okay. To find the terminal point P, determined by any value of t, we use the following steps. Find the reference number t would be our first step, t bar, which we just did. Find the terminal point determined by t bar. And then, so we're talking about first quadrant here. Okay, this is, I'll put Q1. See, t bar is going to take us in the first quadrant because it's always, t bar is going to be less than pi over 2, right? Okay. It's going to be something between 0 and pi over 2. In fact, let's do that. Okay. T bar is between 0 and pi over 2, so it's going to put us in the first quadrant. Okay. And then finally, once we get that terminal point determined by t bar, we're going to say, okay, the terminal point determined by t, which is our original distance, is plus or minus a and plus or minus b, where the signs are chosen according to the quadrant in which this terminal point lies. In other words, the numbers are the same, but the x could change sign and the y could change sign, and we have to figure that out. Okay? So let's look at a couple examples. Let's say find the terminal point determined by each given real number t, where t is 5 pi over 6, okay, or 7 pi over 4, or minus 2 pi over 3. Now the reference numbers associated with these values of t were found in example 5, so we'll refer back to that. Okay, so for t equals 5 pi over 6, our reference number is pi over 6, t bar is pi over 6. Okay, and remember the terminal point numbers for pi over 6 is square root of 3 over 2 and 1/2, right? So we're going to use those numbers, but we're going to figure out which signs we use. Okay, in other words, we're going to use square root of 3 over 2 and 1/2, but we have to figure out plus or minus. Okay, and since t equals 5 pi over 6 took us in the second quadrant, okay, the x-coordinate is negative and the y-coordinate is positive. So we're going to use minus square root of 3 over 2 and plus 1/2. Okay, so we're using square root of 3 over 2 and 1/2, but we're going to change the x to negative because we're in quadrant 2. Okay, our second example, we were looking at t equals 7 pi over 4, and our reference number was t bar is pi over 4, right? We're almost all the way around the circle. Okay, we were just pi over 4 shy. Okay, so remember our terminal point there is square root of 2 over 2, square root of 2 over 2 for pi over 4. Okay, so now that we're in quadrant 4, and that takes us over here, I'll kind of draw a picture here, a small picture. 7 pi over 4 takes us over here, the fourth quadrant, right? So its x-coordinate is positive, and the y-coordinate is negative. Okay, so we're going to have a plus square root of 2 over 2 and a minus square root of 2 over 2 for this t bar, or t equals 7 pi over 4. So our terminal point for 7 pi over 4 is plus square root of 2 over 2 and minus square root of 2 over 2, because we're in quadrant 4, QIV, okay, which means the x is negative, the x is positive, and the y is negative, right? Okay, so that's why, remember this is order pairs. This is your x and this is your y. Okay, in our last example, we looked at t equals minus 2 pi over 3. Okay, our reference angle, t bar, reference number, is pi over 3. Okay, so remember that gives us 1/2 square root of 3 over 2 from our table. Okay, but now, because we're in the third quadrant, the x and the y are negative now, because remember, pi is minus 2 pi over 3 takes us over here. Okay, so we, instead of 1/2 square root of 3 over 2, we have minus 1/2 and minus square root of 3 over 2 for t equals minus 2 pi over 3. Okay, and that's this, it takes us, we're going from here to here, right? Okay, now remember the circumference of the unit circle is 2 pi. So the terminal point determined by t is the same as that determined by t plus 2 pi or t minus 2 pi. Okay, we can add or subtract 2 pi any number of times without changing the terminal point. Okay, because when we add 2 pi, we're just adding a full circle. We're not changing our position. Okay, so if you have larger t's, you can subtract 2 pi's out or add 2 pi's as much as you want to, and it doesn't change anything. For example, let's say we have t equals 29 pi over 6. Now that's a lot of circles, right? In fact, that is 2 circles, which is 4 pi, plus another 5 pi over 6. Okay, 12 pi over 6 is a circle, right? And so we can take 24 pi over 6, which is two circles, right? 4 pi is 2 circles. And these don't count, right? They don't really matter, right? So really what we have is 5 pi over 6. Okay, so the terminal point is the same as that as 5 pi over 6. That should be 5 pi over 6, not 5 over 6 there. Okay, so we can see that the terminal point of t is the same as that of t equals 5 pi over 6. Okay, because this 4 pi is just 2 circles. It doesn't change our position. Okay, and this is what it looks like. We're starting here, and we go 12 pi over 6 all the way around. That's 2 pi. 24 pi over 6. That's 4 pi. And then another 5 pi over 6 gives us 29 pi over 6. So there's 5 pi over 6. Okay. And remember, our reference angle here is just pi over 6. Our reference number, t bar, is just pi over 6. Okay. Which means we're going to use these numbers. Square root of 3 over 2, 1/2. Right? Those are the numbers that correspond to pi over 6. And because we're in the second quadrant, our x will be negative and our y will be positive. So that's why we have minus square root of 3 over 2, and the half stays the same. Okay. So when you're adding circles, it doesn't matter, right? 2 pi, 4 pi, and then another 5 pi over 6 takes us here. And then we're going to use the reference number of pi over 6.